Gaan we nu, oh ja, dat lijkt me helemaal zeer terecht. Dan gaan we nu verder met Tomaso van TomTom. Hij gaat het in het Engels doen, want hij woont slechts zeer kort in Nederland. Dus, nou, Tomaso, please.
Hi tweakers, good to be here, good to see you here, good to see everybody. I'm Tomaso Grossi, I'm a product manager at TomTom Automotive, and today I want to talk to you about something that is really exciting for me, for anybody who is really interested in technology and really passionate about the future of mobility and transportation as a whole. So, what I really want to talk to you about is the perfect storm that is hitting the automotive industry. So, it might sound a bit negative, but it's actually extremely positive trend. So in the next 5 years, the automotive industry and the transportation industry as a whole will see more change, innovation, and disruption than in the past 50 years. And what everybody in the industry is talking about and working on and researching is the self-driving cars. So let's see what the trends are that are shaking up the industry. The first one is the growth of automation. The second one is the increase of connectivity, and the third one is the emergence of the sharing economy. So let's start with automation. Automation encompasses ADAS, which for those of you who don't know, it's quite a technical term, it's Advanced Driver Assistance Systems. So it's one of those systems, for example, like features like lane keep assist, lane departure warning, adaptive cruise control. They are now quite standard in almost every new vehicle that is introduced in the market. Another aspect is HAD, or highly automated driving, which is synonymous for autonomous driving, for example. And also another big trend is the electrification of the powertrain. So automation is definitely the biggest factor here. Cars are becoming more and more autonomous, more and more of the task that the driver undertakes are being taken over by the vehicle. So ADAS features are growing and becoming more and more widespread. You can see them in Toyota Priuses, you can see them in BMW 7 Series. They're across the whole spectrum of cars sold and introduced in the market at the moment. They're labeled from 0 to 5, level 5, in this ranking that pretty much indicates the level of automation of a vehicle. Level 0 being the most traditional manual vehicle, that we are all familiar with, and level 5 being a fully autonomous vehicle. In between, there are different steps. So for example, there are level 1 would be one where there's only one ADAS feature, or level 2, one with 2 ADAS features working together. So increasing on the way towards automation. So some players within the industry, and this is mostly the OEMs, so the car manufacturers, see ADAS as a step-by-step path towards autonomous driving. However, there are different approaches. Tech companies in Silicon Valley, and if we talk about especially Google in particular, they see a different approach towards automation. They want to build a car that is autonomous from the ground up. They want to start from scratch and build a fully autonomous car from scratch. You might have seen the Google pods roaming in the streets or in pictures. Those are fully automated vehicles. OEMs, on the other hand, they want to go step by step through the ADAS features until there's more learning involved. They learn from mistakes and from experience, and then they can build towards an autonomous vehicle. So you see that the automotive industry and Silicon Valley have a sort of a different approach. Some see it in a more revolutionary way from the ground up. Some others see it as a development of cars as we know them at the moment. So regardless of the approach that these players take towards automation, autonomous driving is real, it will happen. It's not a matter of if, it's a matter of when and how. What are the benefits of autonomous driving or highly automated driving? Because we all talk about autonomous driving, but not everybody thinks about what the real effects on life will be. So car safety will definitely increase, even with automated vehicles and not necessarily fully autonomous vehicles. Car safety will increase. Humans are terrible drivers. We crash. We don't have eyes all around us. We don't see cars in our blind spot. Well, sensors and autonomous cars don't have blind spots. They see pretty much, they have a 360-degree view of the car. They see around the environment. They're aware of the environment. Cars will become more efficient and eco-friendly. This is because they will be probably more, let's say, well distributed across the road network. They will load balance themselves around the road network. They will drive in a more efficient way. So imagine, for example, if you're going down a hill, there's no need to accelerate. The autonomous car knows that because it knows the gradient of the road, and it will coast to a stop, for example, at a traffic light. Another key promise of autonomous driving is that drivers will have more freedom, and comfort features will improve the user experience. This freedom is freedom and productivity. So there's two sides. One, you will be more entertained, you'll be able to watch movies, you'll be able to read the news, you'll be able to do all the tasks that you otherwise do in other places and not at the wheel, I hope. And the other side is that productivity will increase. So you'll be able to work from your car, and the car will literally be a third place in between your home and your office. Same level of possibilities and capabilities. So let's move on to the second key trend, connectivity. Connectivity, as we see it, is centered around the connected car, telematics, and especially the digital touch points between the car manufacturer and the customer, and also the growth of big data. So cars used to be pieces of sheet metal with 4 wheels and an engine. And now they're becoming smarter and smarter and more connected. If you think about a Boeing 787, which is the most advanced and modern plane which is in the skies at the moment, that features about 14 million lines of code. A Mercedes S-Class, and probably also Tesla Model S, 90 million lines of code. Just let that sink in for a second. The connected car. So as I was saying, cars are becoming smarter and smarter and more connected. What does that mean? Cars are more connected to the driver and to the user. So you have all these companion applications that the car manufacturers are developing that allow you to, for example, track your vehicle if you lost it. Hope you don't. Lock and unlock remotely your vehicle. You can set up the AC, turn on the temperature. You can even, for example, with the newest Teslas and BMWs, you can even summon your car to come out of the garage while you're outside of the vehicle, just with a touch of a button or with a tap on your smartphone. Other parts of the vehicle are becoming more and more connected. The parts of the engine, parts of the airbag. For example, if an airbag pops, then some connected vehicles will immediately send a message, an e-call, it's called e-call, an emergency message that immediately contacts, for example, an ambulance saying, well, there was an accident in this location, hurry up. Engine failures, for example, can be prognostics and diagnostics can be done, and you could even, for example, schedule automatically an appointment to your dealer for service for these parts. For example, for navigation, connected cars can receive real-time map updates. They can receive real-time traffic information, and this allows the vehicle to route itself more efficiently and get you to destination faster. The connected car is the result of 2 separate words coming together. Automotive infotainment, comprised of navigation, infotainment, messaging, traffic, and music, and telematics, which is more of the tracking and tracing of the vehicle and the communications between the vehicles and the customer, as well as the car manufacturer. And this leads also ultimately to active safety, so ADAS and HID features. If you just think about it for a moment, the merger of these 2 parts, automotive infotainment and telematics, gave birth to pretty much a new industry, usage-based insurance. Now you have a lot of insurance companies offering you these OBD dongles that you insert in your vehicles, and then you pay as you drive or pay how you drive, pretty much. That's revolutionary. It never happened before in the industry. The third major trend is the rise of the sharing economy. This is mainly driven by the younger generations, or as everybody likes to call them, millennials. Millennials are very different from the previous generations, as in they're more mobile, they're more interested in travel, they travel more, they're more open to new mobility opportunities and new forms of mobility. If you look at the different types of trips that millennials and younger people take, just look at the sheer number of modes of transportation that there are there. Millennials and younger generations are used to, for example, taking Ubers, taking Lyfts, using BlaBlaCar, car sharing, ride-hailing, all these forms of transportation that before essentially didn't exist. What is the significance of this? Not just that, people are becoming more flexible. What this means is a threat and an opportunity to car manufacturers, because they have to move from a model whereby they manufacture pieces of metal and wheels to to provide mobility. You see all these new subsidiaries emerging out of Ford, out of GM, out of BMW that are actually just trials of car sharing or ride sharing, and the investments are being made in startups from Silicon Valley. So the model is evolving. Ford stated that they don't want to be in the car manufacturing business, they want to be in the mobility business. They want to enable movement and transportation. So these are the perfect storm, the three trends that are powering the perfect storm hitting the automotive industry. And as we mentioned, autonomous driving is not an if, it's a when and a how. What are the results of these perfect storm, let's say? What will be the effects on your daily life, on your day-to-day life? Traffic. Traffic will definitely diminish because cars will communicate intelligently between them, also with V2V and V2I communication. They will distribute themselves more evenly across the road network, eliminating essentially traffic and congestion. That in turn, for example, will diminish pollution. Parking. Parking is something completely outdated. We now spend 20% of our time at the wheel looking for a parking spot. Then we park there, we pay for it, we walk to our destination, we walk back, we maybe get a fine, and then drive out. That's not how it's going to work. In the future, your car or your shared vehicle will likely drop you at your destination, and then, if needed, proceed to park itself at the nearest parking lot. The space needed for a parking lot will be much smaller because the vehicle, you won't need to be in the vehicle and get out of it. You won't need to open the doors, for example. So spaces would shrink, ideally. Urban planning. Why do we have so many parking spots? There won't be necessarily a need for as many parking lots in the future. Car designs. If you have a look at all the newest motor shows, all the major OEMs are launching vehicle designs without a steering wheel, without pedals, or with, for example, the two front seats that turn around and it becomes kind of a living room situation. So car design will definitely change. Car ownership. This is something that is kind of close to me because I've never owned a car. I've lived in the past 9 years in 5 different countries, and I wouldn't have been able to afford to buy a car. But using ride sharing and ride hailing, this is possible. So I don't feel the need of owning a car. It's an asset that is too heavy for me, and I'm fine with using Uber, for example. Transportation on demand, same thing. You could have different, driverless pods picking you up and dropping you off and then being reassigned to other users. Access for all, if you think about for people who now are not able to drive, if you think about the elderly, the ill, and for example, the children. Children right now, of course, are not allowed to drive. They cannot get a license. With a self-driving vehicle, why would you need a license? You could, instead of dropping your kids off to school and then going to work, you could have a pod deliver your kids, bring your kids to school, and then go to the office. And business models, of course, ownership will shift, ownership will change. And this brings me to my next slide, which is the future vehicle value propositions. So there is consensus within the industry that there will be ideally two types of car-based transportation. One is a privately owned autonomous vehicle, which is more maybe adapted for families, and it will be more of a statement and for people who value freedom even a bit more. And then there will be shared autonomy. So this will work likely in urban environments, advanced urban environments, and you will have, for example, pods driving around and picking people up as if it was an Uber or a Lyft without a driver in it, that you can simply summon with your mobile phone. So how does TomTom connect with all these trends that are rocking the industry? It's every player is adapting to these trends. How is TomTom connecting with these trends? So our value proposition and our product offering has always been, in the beginning, a purely embedded navigation offering. So in the head unit of the vehicle, you would have your navigation. And then we realized the trend of connected car. And so we started offering components, navigation components that are more and more connected, that allow you to perform more and more and to get more and more out of your driving experience. And now we're working hard and investing heavily towards creating products and launching products that are key enablers in automated driving and working with some of the key players in the industry. So what are our components? Our connected services, for example, our traffic information, our parking information, as well as our navigation software that helps you route around traffic and get to your destination as quick as possible, as well as real-time maps. Now, maps is something that I really want to emphasize because not too many people talk about the importance and the validity of maps for automated driving. But if you think about it, if you remove the driver from the equation, how does the car exactly know where it is located, where it is going? So there are essentially two needs in terms of maps for autonomous driving. One of them is up-to-date maps. The vehicle needs to know exactly what the road ahead looks like. You cannot have, for example, there are changes in the road. New roads are built, other roads are closed, lanes are added, lanes are removed, intersections are added. If the car is not aware of these changes, and if these changes are not fed to the car could eventually crash in the worst case scenario, or drop to a standstill or not know how to proceed. So this is why we saw this trend coming, and we identified this opportunity, and we thought we need to develop a system to deliver real-time updated maps to vehicles, especially in the context of automated driving. So we built a transactional map-making engine that is unmatched in the industry. This allows us to close the loop between realizing the changes that are happening to the roads in the real life, in the real world, and sending it as an update to the users, to the driver's head unit in the vehicle. So it's a sort of, you know how, for example, Tesla started working on over-the-air updates? This is something in a way similar. So how do these play within the connected navigation experience and ADAS and automated driving experience? They both fit into this. Some components are more geared towards automated driving, and these are the ones that I actually would like to talk to you about. I think they're very exciting. The first one is high-definition maps for automated driving. So the key that we talked about before is to have a real-time updated map, up-to-date maps with the newest information. The other one is to have an incredibly detailed map. Because as a self-driving vehicle, you don't want to know, yes, well, okay, there are 2 lanes in this road and I have to take a right. You want to know the width of the lane, you want to know exactly the lane markings, where they are, exactly where the next intersection is, with extreme accuracy. The typical navigation and maps that we know for today's navigation is not enough. We need much more accurate maps and much more accurate information. The solution is HD maps. So it's highly detailed, highly accurate, and richly attributed maps. They are much more accurate, much more precise, and are perfect for automated driving. The next product, this is very exciting, it's called Road DNA. So GPS has its limitation. It's the most widely used positioning tool, but it does have some limitation. Namely, it's just not accurate enough for automated driving. So what we set out to do is develop a system that allows you to position the vehicle perfectly within the road with about 50 centimeters longitudinal and 15 centimeter lateral accuracy. What it does, it takes a 3D point cloud of the road and compresses into a 2D view of the roadway on the side of the roads. So the idea is that if you're driving a vehicle with sensors and cameras, those correlate the view from the sensors and the cameras with the database of the roadside, of the roadway, the side of the road. And it can match exactly where you are with a pattern recognition system, and also the algorithm is flexible enough to allow, for example, for changes to the roadside. So for example, if you have a tree and the tree is either cut down or leaves fall, for example, that's still the algorithm is still flexible enough to even detect that, and no problem. It's still accurate and efficient. So this is a quick video that I wanted to show. This is what you see. This is what the driver sees. That is what the car sees. So it's very light. It's about only 25 kilobytes per kilometer. And so this is made with data processing and data storage clearly mined. It's very dynamic, very robust. You get the idea. So these are the three, as we mentioned, trends hitting the perfect storm that hit in the automotive industry. And some players see it as a, as a challenge or as a threat to their common business. But as TomTom, we see it as an opportunity to innovate and to engage and be active in areas we hadn't even thought of. And we're really excited. And as the old adage goes, a smooth sea never made a skillful sailor. So we're happy to be in this space, and we can hope that you come check out at our open day to learn more, and we can show you more demos of our technology and learn more about the exciting trends in automated driving and the road to autonomous driving. Thank you.
Well, Tomaso, thank you very much. I have too many questions myself, but I suppose there are quite a few in the public. So there's the first one.
Thank you. We almost made the same mistake. So really cool work with the maps. But I'm curious, if I drive to Amsterdam, I don't have all these detailed maps in my head. I just use my eyes and still get there almost all the way. So why do you exactly need all those really, really detailed maps? And can't you do without really good environment perception with the point clouds and just read the speed signs from the cameras, for example, and the signs on the road, where to go, etc.?
Cool. So you mean, for example, just to understand the question, you mean why are, for example, maps needed as opposed to just using sensors, right?
Basically, yeah.
Yeah, clear. That's a really good question. It's a question that we get quite a lot. And we see, for example, players like Mobiliteit. I'm not sure if you're familiar with Mobiliteit, but it's one of the main manufacturers of cameras and sensors in the industry, and they work with pretty much every car manufacturer. And they also suggest that maps are needed, because the thing is, sensors are quite accurate, but in some situations they don't necessarily work. So cameras don't really work that well in low light. Sometimes they don't work that well in adverse weather. That's not the only limitation. They're also less accurate, and sensors only see about maybe 300 feet ahead, some types of sensors. So you need to know, for example, the road ahead. You need to know the planning, the routing, which route you're going to take, and that is empowered through the map. Not necessarily only that, but for example, sensors don't necessarily see around corners. So the way that I usually try to explain this is, imagine yourself in a corridor, and you're walking in this corridor, and they turn the lights off, completely dark. You don't know where you're going. You kind of like the first probably intuition is to touch the walls, right? And that's sort of what sensors do. You sense what's around you. You see, okay, tick, 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 there's a car. Tick, 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 there's a car. Lane marks and lane markings in general. With a map, is as if you opened your eyes and you could see the destination at the end. You could see much more detailed. And also, it's also a matter of building redundancy, right? Because you don't want a whole car with 4 passengers and lives on it relying on one sensor that costs $20, right? So it's all about building more and more and more redundancy. So it's maps are a redundancy to sensors, and the other way around too.
In the middle. Oh, Sim is running towards you.
Good evening, everybody. Tomaso, I have a question. Mostly these cars are accepted by user experience, and that's also what you said. Do you see any hope for the people who actually get their user experience from actually driving the car, like with a manual gearbox, for instance?
Absolutely. So as I mentioned, and there are different types and different consensus within this. So some people think that it will be just like sort of like white pods driving around, kind of like soulless. I understand what you mean, but the models of ownership will definitely change. So you will see a different spectrum of mobility options. So you will have your traditional vehicle that you can drive that can also enter in autonomous mode. So right now, for example, you have vehicles like, imagine the Tesla Model S, where you can hit a button and it starts into autopilot. That way you can either drive your car, as you've always done, or you can hand over to the car the control. So I think it will be a mix of the two. So you will have, of course, the vehicles that are there, and the cars that are fun and exciting to drive, but at the same time, you will also be able to hand off to the vehicle the driving experience if you want.
I think the next question is already...
Yeah. Here in the Netherlands, we have a very good road network, and markings are mostly clear, and traffic rules are obeyed. But in other countries, road signals and markings can be very iffy, and the traffic degrades into sort of chaos.
I'm Italian, I know.
Yeah. And how are you planning to deal with more complex road systems?
Of course.
Yeah.
No, I understand. Really good question. Also, if you think about it, even roads without road markings, that are marked very well. How do the sensors in the car see those? So the answer to that is, in a way, deep learning, for example, and machine learning. So you have some players within the industry that are experimenting with deep learning and, for example, convolutional neural networks. These pretty much teach the car to understand where the road is no matter what. So even if there's the lane markings sort of vanish or are not well marked, the car still understands where it is and where the road is. So that is one part of the answer. So it's not necessarily just having like sensor redundancy, but also sensors and vehicles that learn and learn and learn just like a human would, which is extremely interesting and fascinating. The other one is the way that this will be rolled out in a geographical way. So in a way, for example, if you think about all the innovation that is going around driverless vehicles, many OEMs, car manufacturers, and tier ones, they're moving to Silicon Valley because it's an environment where the infrastructure is advanced, everything is quite new, and it's a good fit. It's more of a controlled environment. So the way that I see it, and the way that many people and analysts in the industry see it, is that it would be rolled out initially in advanced environments, such as, for example, Silicon Valley, but also the Netherlands. And then it will proceed to, once the learning is done in those kind of environments, then it will proceed to spread out more globally.
We have time for one, maybe two questions. Test. Yeah.
Hi. So it all sounds very nice and a very spectacular sketch of the future. But my question really is, how are you going to handle, with all these new systems, hopefully happening in the future, old cars? Because there are a lot of people who can't afford the new technology, even though it's shared. How are these systems going to communicate with, an old piece of junk that's also still driving?
That's a very good question. Because if you think about it, cars usually, right now, they have a lifetime of about 9 to 10 years. So it's going to be very difficult to, have the whole turnover of every vehicle being introduced with this new technology. The partial answer to that is aftermarket. So if you see a company, for example, called Cruise Automation that has been acquired by GM for about $1 billion 2 weeks ago, I believe. They provide a sort of piece of hardware that you can put on the roof of your vehicle. I think only Audis up to a certain model, but still aftermarket, and it gives your vehicle self-driving abilities. So part of the answer will be for aftermarket. Another part will be that not necessarily all vehicles will be autonomous, and I don't believe that all vehicles will be autonomous, at least while I'm alive, because essentially they will be initially rolled out in urban environments. They're a better fit for urban environments. If you think about Uber, for example, Uber is investing heavily in this technology because 60% of a taxi fare goes to the driver. And what they want to do is eliminate the driver. So they will slash cost, and they will also make more money. So what they want to do is eventually have, in urban environments, have vehicles driving around and picking passengers up. But for a drive, for a long drive, for example, or for drives in poorly marked or poor terrains, let's say, poorly marked roads, you won't necessarily have a self-driving vehicle, or at least it might not, the technology might not develop that far that self-driving is available everywhere on the globe, and I don't think that's coming anytime soon.
Well, that's some timing. It's exactly 8 on my watch, so thank you very much, Tomasi.
Thank you.